Hello friends, you are watching channel number Coolage. Through this channel, we take sincere efforts to make you understand and like mathematics, science and engineering in a simple and easy manner. In this video, we will understand direct and inverse proportion. In this, we will discuss how two related quantities increase or decrease together proportionately, or if one quantity increases, the other related quantity decreases proportionately. First, we will talk about direct proportion. To understand direct proportion, we will consider two examples. Number one, if the number of articles purchased increases, their total cost also increases. Here, number of articles is one quantity and total cost is another quantity. Number 2, if less money is deposited in a bank, less interest will be earned. Here, money deposited is one quantity and interest earned on that money is another quantity. If one quantity increases or decreases, increases or decreases, the other quantity also increases or decreases proportionately, increases or decreases proportionately. When the two quantities change in this manner, it is known as direct proportion. Suppose a quantity y is directly proportional to its related quantity x. We write y alpha x and y equals kx, where k is a constant. Or we write y divided by x equals k. So, in direct proportion, the ratio of the two related quantities is a constant. In general, we write y1 divided by x1 equals y2 divided by x2 equals k, where k is a constant of proportionality. For simplicity, we can write it as x1 divided by y1 equals x2 divided by y2 equals k. In case of the examples that we have discussed, if the number of articles purchased increases, the total cost also increases. Therefore, the number of articles is directly proportional to the total cost. Here, number of articles divided by total cost is a constant. In the second example, more the money deposited in a bank, more will be the interest earned. Therefore, the money deposited is directly proportional to the interest earned. Here, money deposited divided by interest earned is a constant. An electric pole 14 meters high casts a shadow of 10 meters. Find the height of a tree that casts a shadow of 15 meters under similar conditions. Let the height of the pole y1 be 14 meters. Length of its shadow x1 is 10 meters. Height of the tree y2 we have to find out. Given that length of the shadow x2 equals 15 meters. As height of the object increases, height of its shadow also increases. So there is a direct proportion between the two quantities. We have x1 divided by y1 equals x2 divided by y2. We will substitute the values. x1 is 10, y1 is 14, x2 is 15 and y2 we have to find out. We get 10y2 equals 14 multiplied by 15. So height of the tree y2 is 14 multiplied by 15 divided by 10, that is 21 meters. So height of the tree is 21 meters. If the weight of 12 sheets of thick paper is 40 grams, how many sheets of the same paper would weigh 2.5 kg? We will use unitary method. In this, we write 12 sheets of paper weigh 40 grams. It is given here. We will assume X sheets of paper will weigh 2.5 kg. That will be 2.5 multiplied by 1000 gram. That will be 2500 grams. So in unitary method we write 12 divided by x equals 40 divided by 2500. Now this 0 gets cancelled with this 0 and we write 4 multiplied by x, 4x, and 250 multiplied by 12, 250 multiplied by 12. So that gives us x equals 250 multiplied by 12 divided by 4. 4 3s are 12, so it will be 250 multiplied by 3. That will be 7500 sheets. So 7500 sheets will weigh 2.5 kg. A train is moving at a uniform speed of 75 kilometers per hour. Number 1. How far will it travel in 20 minutes? Number 2. Find the time required to cover a distance of 250 kilometers. Speed of the train is 75 kilometers per hour. We know that speed is distance upon time. So let it be x1 divided by y1, which is given as 75. So x1 divided by y1 is a constant. Number 1, how far will it travel in 20 minutes? That we have to find out. Convert 20 minutes into hours. So we have y2 equals 20 minutes, which will be 20 divided by 60 hours. That will be 1/3 hour. We have to find out x1, that is the distance traveled in 20 minutes. We have x1 divided by y1 equals x2 divided by y2 in case of direct proportion. We will substitute the values. We have x1 divided by y1 equals 75, so we put 75 here, equals x2 divided by 1/3 because y2 is 1/3. So that gives us 3x equals 75. This 3 goes up in the numerator. So x2 becomes 75 divided by 3, which will be 25. So the train will travel 25 kilometers in 20 minutes. So that's our answer. Second question, find the time required to cover a distance of 250 kilometers. We have distance x2 equals 250 kilometers and we also have x1 divided by y1 equals x2 divided by y2 for direct proportion. We have x1 divided by y1 equals 75 and x2 equals 250. So it becomes 75 y2 equals 250. That is, y2 will be 250 divided by 75. It will be 3.33 hours, that is 3 hours 20 minutes. So to cover 250 kilometers, 3 hours 20 minutes will be required. The scale of a map is given as 1 ratio 30 000 000. Two cities are 4 centimeters apart on the map. Find the actual distance between them. There is a direct proportion between the distance in the map, which is x, and the actual distance y. Distance in the map is given as 4 centimeter, which is x2. We have, for direct proportion, x1 divided by y1 equals 1 divided by 30 000 which is given. Now we have x1 divided by y1 equals x2 divided by y2 for direct proportion. We will substitute the values. For x1 divided by y1, we write 1 divided by 30 000 equals x2 is 4 centimeter. So for x2, we will put 4 divided by y2. We get y2 equals 4 multiplied by 30 000 centimeters, which will be 120 000 centimeter. To convert centimeter into kilometers, we have to divide by 100, which makes centimeter to meter, multiplied by 1000, which makes meters into kilometers. This 5 zeros cancels with these 5 zeros, and we are left with 1200 kilometers. Actual distance will be 1200 kilometers. A machine in a soft drink factory fills 840 bottles in 6 hours. How many bottles will it fill in 5 hours? Here, number of bottles Y is directly proportional to the time required to fill them, which is X. So for direct proportion, we have x1 divided by y1 equals x2 divided by y2. We are given y2 equals 5 hours. That is, we have to find out how many bottles will be filled in 5 hours. We will substitute the values 840 for x1, 6 for y1, 5 for y2. We get 6x2 equals 840 multiplied by 5. x2 will be 840 multiplied by 5 divided by 6. 840 divided by 6 will be 140 multiplied by 5. That gives us x2 equals 700. So the machine will fill 700 bottles in 5 hours. To understand inverse proportion, we will consider two examples. Number one, if we increase the number of workers, time taken to finish a fixed job decreases. Here, number of workers and time taken are two related quantities. Number two, if we decrease the speed of a vehicle, time taken to cover a fixed distance increases. Here, speed of the vehicle is one quantity and time taken is another quantity. If one quantity increases or decreases, the other quantity also decreases or increases proportionately. When two quantities change in this manner, it is known as inverse proportion. Suppose a quantity y is inversely proportional to its related quantity x. We write it as y alpha 1 divided by x, or xy equals k, where k is a constant. So in inverse proportion, the product of the two related quantities is a constant. So in general, for inverse proportion, we can write x1 y1 equals x2 y2 equals k, where k is a constant of proportionality. 6 pipes are required to fill a tank in 1 hour 20 minutes. How long will it take if only 5 pipes of the same type are used? Let number of pipes be y and time required to fill the tank be x. If the tank capacity is fixed, then y alpha 1 divided by x, that is, y is inversely proportional to x, which implies xy equals k, where k is the fixed tank capacity. We also have x1 y1 equals x2 y2 equals k in case of inverse proportion. We will substitute the values. We have 1 hour 20 minutes for x1, the time, 6 number of pipes equals x2 multiplied by 5 number of pipes. So we have to find the time taken, that is x2. 1 hour is 60 minutes, 60 plus 20 becomes 80 minutes, multiplied by 6 equals 5x2. So 5x2 becomes 480, which is product of 80 and 6. So x2 becomes 480 divided by 5, which will be 96 minutes. So the time required will be 1 hour 36 minutes. So 5 pipes will take 1 hour 36 minutes to fill the tank. There are 100 students in a hostel. Food provision for them is for 20 days. How long will these provisions last if 25 more students join the group for a fixed food provision? Number of students y1 is 100. Number of days for which the provisions will last x1 is 20 days. Number of students added is 25. So the new number of students y2 becomes 100 plus 25, that is 125. We have to find the number of days x2 for which the food provision for 125 students will last. Here we observe that y is inversely proportional to x, that is xy equals k, where k is the fixed food provision. We also have for inverse proportion x1 y1 equals x2 y2. We will substitute the values 20 for x1, 100 for y1, 125 for y2, and we have to find x2. So x2 becomes 20 multiplied by 100 divided by 125. 25 fours are 100 and 25 fives are 125 and 5 fours are 20 and 4 multiplied by 4 is 16. So x2 is 16 days. That is, the food provisions will last for 16 days for 125 students. If 15 workers can build a wall in 48 hours, how many workers will be required to do the same work in 30 hours? Let number of workers x1 be 15. Number of hours y1 is 48 hours. Number of workers x2 we have to find out when the number of hours given y2 is 30 hours. For the fixed amount of work, we have y alpha 1 divided by x, that is, y is inversely proportional to x. Or for inverse proportion, we have x1 y1 equals x2 y2. We will substitute the values. 15 for x1, 48 for y1 and 30 for y2. x2 will be 15 multiplied by 48 divided by 30. 15 2s are 13 and 48 divided by 2 will be 24 workers. So if we reduce the time from 48 hours to 30 hours, more workers, that is 24 workers instead of 15, will be required to build the wall. So this is about direct proportion and inverse proportion, in which we have seen how two related quantities change in case of direct proportion and inverse proportion. If you like this video, please subscribe this channel. Share this video with your friends and relatives. Thanks for watching. Have a nice day. Keep watching Number Collage.